Imagine, if you will, a world where the secrets of energy, heat, and the universe's ultimate rules are hidden within every gust of wind, every boiling kettle, and every blazing sun. This is the world of thermodynamics, a field of study that has not only shaped the physical sciences, but has also ignited the minds of some of the greatest thinkers in history. Let's travel back to the 1800s, a time of steam engines and the Industrial Revolution, a period bustling with inventions and discoveries. In this vibrant era, a young French military engineer named Sadi Carnot made a discovery that would forever change how we understood energy. Carnot, fascinated by the power of steam engines, pondered a simple yet profound question: how can we make these engines more efficient? Carnot's investigations led him to formulate a principle that seems almost magical: no engine, however ingeniously designed, could ever be perfectly efficient. There's always some energy lost, usually as heat. This might sound like a limitation, but it actually opened up a whole new way of understanding the workings of the universe. This was the birth of the second law of thermodynamics, which states that in any energy exchange, if no energy enters or leaves the system, the potential energy of the state will always be less than that of the initial state. A principle explaining why perpetual motion machines are a mere fantasy. Now, let's fast forward to another brilliant mind. Ludwig Boltzmann, an Austrian physicist who lived in the late 19th century. Boltzmann was captivated by the behavior of atoms and molecules. With his profound insights, he connected the microscopic motions of atoms to the macroscopic phenomena of heat and energy, a groundbreaking move that helped establish the field of statistical mechanics. Imagine tiny particles, all invisible to the naked eye, moving and colliding in a dance dictated by laws that Boltzmann helped to uncover. His theories explained how the properties of atoms influenced everything from gases to liquids to solids, and how these changes involve energy transfers that obey specific thermodynamic laws. But perhaps the most intriguing aspect of Boltzmann's work was his interpretation of the second law of thermodynamics, the idea of entropy, a measure of disorder in a system. Entropy always increases, he argued, in a closed system. This concept, though initially contentious, eventually paved the way for a modern understanding of thermodynamics, and indeed, the fate of the universe itself. Boltzmann's life was a testament to the passion and curiosity that drives scientific discovery, but it was also marked by tragedy. Despite his profound contributions, he faced significant opposition from some contemporaries, which led him to despair and ultimately to his untimely death. Yet, his legacy lives on in every corner of modern physics, influencing theories from the smallest particles to the dynamics of black holes. So the next time you boil water for tea or feel the warmth of the sun on your face, remember the extraordinary tales of Carnot and Boltzmann. These were not just scholars. They were adventurers at the edge of human knowledge, deciphering the cosmic puzzle of energy, heat, and disorder. Their stories are not merely accounts of scientific discovery. They are narratives of human curiosity. To help and automatic meetings. African American. Let their journey inspire you to look closer at the world around you, to question, explore, and maybe even to follow in the footsteps of these pioneers of thermodynamics.